Okay, this is chapter 3.2, characteristics of quadratic functions. Some of this you may already kind of instinctively know, you just may not be able to put it in words, but we're going to pull off certain pieces of information based upon the equations and things along those lines. Alright, so if I've got the properties of a graph in standard form, so this is a standard form equation. First things first, my axis of symmetry right down here, this line right here, is the equation x equals negative b over 2a. Alright, so basically I take whatever b is, divide it by twice a, and flip the sign. Alright, so it's b divided by 2 times a, the negative of that. That gets me my axis of symmetry. Okay, same thing over here. Alright, even if it opens downwards, a is less than 0. I can get my axis of symmetry, from the equation x equals, negative b over 2a. Exact same formula. That can help me get the x-coordinate of my vertex. Alright, the x-coordinate, same idea, is negative b over 2a. And if I want the y-coordinates, f of negative b over 2a. I take whatever that number is, and I plug it in for x, and I solve. Okay? So that's just another way of getting the vertex from a standard form equation. Alright? So here we go. The parabola opens up when a is greater than 0, and it opens down when a is less than 0. Okay? Alright, basically, when this is positive, it opens up. When that's negative, it opens down. The graph is narrower when the absolute value of a is greater than 1. Basically, here's what that means. The graph starts shrinking, starts getting more narrow and more narrow when you have the further away you get from 1. So like 2, 3, 4, 5, 6, 7, 8, the graph is going to get really, really skinny. Okay? Even in negative 2, negative 3, negative 4, negative 6, it's going to get really, really skinny, just open downwards. It's going to get wider when the absolute value of a is less than 1. So basically, or let's think of it this way. You can also think of that as when a is greater than 1 but less than 0. When it's between, not 0, when it's between negative 1 and 1. That's when you're multiplying the whole thing by like a decimal, like 1/2 or 0.7, something on those, whether it's positive or negative. The graph is going to open, whether it opens up or down, it's going to get wider and wider. So this makes a really wide graph. This makes a really skinny graph, whether it opens up or down. Okay. The axis of symmetry is, I'll do it in a different color to make life a little easier. Negative b over 2a. Alright, and you can sometimes you put the negative up there, that's fine, doesn't matter. And the vertex is, your x-coordinate for your vertex is negative b over 2a, just like the axis of symmetry. Because remember, the axis of symmetry and the vertex go in the same spot. But to get the y-coordinate, you simply plug that into the function. So take negative b over 2a and plug it in for x. Alright. And last but not least, the y-intercept is c. Alright, so the point 0c on the graph. Alright. That is this one right here. Whatever the y-intercept, whatever that number is, that's your y-intercept. Okay? That's a little confusing looking. Alright, let's move to the next one. Alright, this is the core concept for intercept form, okay? So when you've got f of x equals a times these two factors, okay? And we'll talk more about factors and that sort of stuff in a different lesson. But because those are my x-intercepts, because those are my factors, P and Q are the x-intercepts. So I can plot them right there. All right. The axis of symmetry is halfway between P0 and Q0. So it's halfway between those 2 points. All right. So let's go ahead and label these. This one is P0, P comma 0. This one is Q comma 0. Okay. So if you want a formula for that, which you're more than welcome to have, you can do x equals the average of them. Add them up, divide by 2. The middle point, P plus Q divided by 2. If you ever want to know what is directly between two things, you average them. Add them up, divide by 2. All right? Even if it was a negative. All right? Let's say even if P was over here, you know, instead of over there, you still add them up, divide by 2, you'll find the middle. Okay? And again, the parabola opens up when a is greater than 0, and it opens out down when a is less than 0. All right. So if I were to label my graph a little bit, which I haven't done, my axis of symmetry right there is at the equation x equals P plus Q divided by 2. So average those together, and you'll get the axis of symmetry. And this graph right here is my vertex form, not vertex, intercept form. A, x minus P, x minus Q. So mind your P's and Q's. Sorry, really bad joke. Alright, I think we got more core concepts. Alright, last core concept, all about maximum and minimum values. Alright, for the quadratic function, f of x equals ax squared plus bx plus c, so standard form. The y-coordinate of the vertex is the minimum value of the function when a is greater than 0. And the maximum value when a is greater than 0. So basically, the y-coordinate of the function is the minimum when it's at a is greater than 0. And it's the maximum when a is less than 0. Okay? And remember, your axis of symmetry is this bad boy right here. That is your axis of, let's draw that a little bit straighter. This is your axis of symmetry. There we go. And same thing with this one, your axis of symmetry right there. So this is also x equals negative b over 2a. Okay, and another thing, we're going to talk about when things are increasing or decreasing. The graph is considered decreasing when it has a negative slope, and it's increasing when it has a positive slope. Okay, same thing over here. So this one, this half of the graph has a positive slope. So over here, when a is less than 0, the left side is increasing. And over here is decreasing. Okay? So, let's start dealing with this. Your minimum value, well, that's the y-coordinate of your vertex. Okay, minimum and maximum, whatever that is, that's the y-coordinate of your vertex. So for both of those, we can simply put f of negative b over 2a. F of negative b over 2a. Alright? The domain for both of these functions, well, both of these go left forever and right forever. So the domain is all real numbers. All parabolas, well, I should say all vertical parabolas. We'll talk about horizontal parabolas in a different one, but all parabolas that face up and down, the domain is all real numbers. The range, so if it opens upwards, y is greater than whatever, greater than or equal to, I'm sorry, f of negative b over 2a. It is greater than your, I'll just write that That's your minimum. It's greater than your minimum. Now, if you've already figured it out, you don't have to recalculate it. Just throw the minimum right there. All right? Your range is just the same idea, but it's less than, because it's opening downwards. F of negative b over 2a. That is your minimum. All right? And remember this one. So this was decreasing to the left of. So it all has to do with increasing and decreasing. Well, this one was decreasing on the left side of my axis of symmetry. Well, your axis of symmetry is still x equals negative b over 2a. And it was increasing to the right of x equals negative b over 2a, that line. Remember, your axis of symmetry is a line, so you have to write it as an equation. For the one a is for negative 0, and the one that's opening downwards, on the left side it's increasing, so the left of your axis of symmetry, and it's decreasing to the right of it. Now, take a look at this. You'll notice that you may think, oh my gosh, that's a ton of formulas. You notice how it really is just the same stinking thing over and over and over. All right? That little negative b over 2a gets you a lot. It can get you your negative, it can get you your minimum, your maximum, it can get you your vertex, it can get you where it's increasing, where it's decreasing. That little negative b over 2a is a very, very powerful little expression. All right? So that you do have to memorize. And from there, you just got to know how to apply it. All right? That's it.